Okay, so in this question we've got these two functions. So we've got function y equals e to the x and y equals 2x times x squared take 4, and we've got some area between them. Okay, so according to this graph, kind of goes right this and goes up, and that's the 2x x squared take 4, and e to the x kind of goes something like this. Okay, and we've got this shaded area here. Okay, so let's have a look at what we've got here. So let's say that we'll call this shaded area P and this shaded area Q. And so there's some points of intersection here which are going to be useful to us. So let's call them A, B, and C. Okay, so write an integral that can be used to determine the area of the shaded region. Okay, so the shaded region is this area P. So the integral that we'd use for that is the integral, definite integral from A to B of, okay, so which function's higher? So this polynomial function, this second one here, is higher, so that one goes first. So say 2x times x squared take 4. Subtract the area of the other one, the integral of the other one, dx. Okay, so the reasoning behind that is that we've got this curvy function here, so that's the whole area, but then we've got this exponential function here, so we have to subtract this area under here, and that gives us this area that's trapped by those two curves. Okay, so let's first of all figure out what those points of intersection are. So the points of intersection are when the two functions are equal, so e to the x equals 2x times x squared take 4. Plug it into your calculator, and you'll get values of x equals minus 1.991, minus 0.112, 2.552, and 5.891. Okay, so the reason I said is because we've got this number up here. So it looks like we've got this point C, which is 2.552, but further up here, it looks like the graphs actually cross over again. So we've got a point up here, which we'll call D. So we'll come to that later. We don't need that straight away. So the area that we're looking for, this area P, is the integral from minus 1.991 to minus 0.112 of this function. So remember again, it's a polynomial, subtract exponential, dx, and we can plug that into a calculator, and you get the answer, approximately 7.19. Okay, and whatever it is, it doesn't say whether it's centimeters or anything, but something squared. Okay, because that's area. Okay, so then the next part, okay, I think this is where we're going to have to use this value that we calculated here. Determine the area of the region trapped between the two curves for x greater than or equal to 0. Okay, so first of all, I thought it was just going to be Q, but there's two problems with that. So Q is this area in here, but just be careful, because if you look at Q, which I've just shaded in here, it includes a little area which is negative over here, and we're asked to find it for only x greater than or equal to 0. So that means from here. Also, because we found out there's another point of intersection up here, there's this other little area here, which I haven't drawn very well, but that's another area that's trapped between the two curves. So really, the area is from 0 to this point, the integral, and then from this point to this point. So the total area, and I'm going to do this carefully, so from 0 to 2.552, okay, so which of the points, which of the graphs is higher? So from 0, this e to the x graph is higher, so it's that one, subtract the other one, and then add on that second area, which is going from 2.552 to, 5.891, and this time the other graph is higher. So the 2 to the 2x times x squared take 4 is higher, subtract e to the x dx. Okay, so it says we don't have to evaluate it, so that's our answer.